Great. Yeah. All right. Thank you so much for having me. I'm really excited to be here. I think this is maybe the fifth time I've presented at an Our Ladies meetup, but never at Baltimore. One maybe in person. That would be very fun. Yeah, I am super excited to talk to you all about tidy models today. So several of you have probably already seen my blog post on it. Let me share my screen. One thing I want to plug for is Stephanie kind of mentioned you, who is my PhD advisor and kind of my mentor, and she and I are writing a book called Veridical Data Science that we've signed a contract with MIT Press, and we're hoping to have it out within the next year. And there's going to be a free online version. So it's all about data science. I can go on about that, but I just wanted to put that out there, put it on your radar. It's going to be really exciting. Okay, let me figure out which window I'm trying to share. I am trying to share this one. All right, can you all see my screen? Should be a Chrome window.
I see it, yes.
Great, fantastic. Okay, so all the materials I'm going to go through today, you can find them on my GitHub. I just made a quick little repository which has an IPython notebook that contains all the materials. And the neat thing about making talks in Jupyter notebooks is you can use something called Binder that I'll show you about in a moment. So if you want to go navigate to this GitHub repository, which is Barter, which is also my name on Twitter, by the way, Tidy Models Talk, and you hit this Launch Binder button, you're going to have a notebook pop up with all the materials that I'm going through today. So I just wanted to make sure everyone has access to that. The blog post that I wrote March 2020, what was going on then? It felt like a normal life. You can find it here. It's on my website, and there are some things that are slightly different now. I think some things are slightly simpler now than they were, specifically to do with extracting things from the final object. There's a lot of stuff that's changed there. This is still, I think, a good resource for kind of getting an overview. A lot of the stuff I'm going to go through today is based on that. Finally, I think the best resource right now, if you want to get a deep dive and really kind of commit to learning tidy models, is this book written by Max Kuhn and Julius Silge, which is, Max Kuhn was kind of the guy who actually wrote Carrot, which was the kind of R package ecosystem of machine learning that preceded tidy models. And they wrote this fantastic book that has all the information that you need. But yeah, let's get started. I love questions. So if you have any questions, feel free to type it in the chat box. And, I always welcome interruptions. I like having conversations rather than talking at people. It's obviously difficult to do with so many people. So I think we can kind of field maybe through Stephanie and Margaret questions. But let's get started. So I also want to do a little plug for this Rise plugin. If you've ever used Jupyter Notebooks before, there's this really nice plugin. You can turn your notebooks into slides, which I find a really nice kind of balance between live coding in RStudio. I mainly use RStudio, and having some kind of structured talk. So yeah, here are some links to the book and the blog post. And you can find me on Twitter at RLBarter.
Rebecca, as we get started, there's a question. Is tidy models intended to replace Carrot?
Yes, I think it is. I mean, I think Carrot isn't going to disappear, is my understanding, because if you have code that uses Carrot, it will still work. But I think Max and the whole tidy models team, which is expanding, it seems like, I think they are focusing mostly on tidy models as the future rather than Carrot.
And is there a
Thank
name?
You for the question.
Is there a name of the R package that turns your notebook into slides?
So this isn't an R package. So this is, I literally am at a Jupyter notebook, and you can install a plugin called Rise, R-I-S-E. And then you end up with this little menu on the side of each of your Jupyter code things. We turn them into slides and fragments and sub slides. And then you just hit this button, and it's like, bam, a slideshow, and it's interactive and it's fantastic.
That's
highly recommend. I give a lot of my talks with this. Yeah, it's really cool.
nice.
Because it means I don't have to like write everything out now. And I can kind of navigate a little nicer.
Thanks.
Yeah, thank you so much for those questions. I appreciate it. Yeah, so okay, I just want to quickly introduce the data set we're going to be working with. So first thing I'm going to do always is load the tidyverse. I'm not going to talk too much about the tidyverse. Just mainly talk about piping. If you've never seen the pipe before, I'll give a quick kind of explanation of what it's doing when it comes up. And then I'm using this Peanut Indians diabetes data set from the ML Bench library, which if I run this chunk, which hopefully my internet is working, great. We can look at it. So it contains 9 variables. The thing we're trying to predict is diabetes status for these women based on number of pregnancies, glucose levels, pressure, tricep measurement, insulin, mass, pedigree, and age. So I just kind of like to have a picture in your head of the data set we're going to be working with. I always like to do a quick little exploration of, obviously I would do more than just a single histogram of one of the variables, but let's look at the triceps variable. And there's something weird going on. So you can kind of see there's like a normal distribution of like, it's like most people have a tricep measurement. I think measurement is like, there's like something that you measure like tricep fat, I guess. And it's like related to body fat. But there's a bunch of measurements that are 0, which seems implausible unless those people are skeletons, which they are not, I'm sure. So one quick little thing I want to do, I'm not going to kind of go through this code. I just want to like emphasize the fact that you need to do some kind of pre-processing before you're kind of ready to go. And I'll show you how to do that really easily in tidymodels. I'm going to find a clean version of the data where I replace 0 entries in several of the variables with missed values. And I'm using this kind of like mutate at syntax and a pipe. The pipe, which you're going to see a little bit in this talk, is basically it takes the object on the left. So it takes like diabetes orig, and it puts it into the first argument of the function on the right. I'm not going to talk too much about what this code is actually doing, but let's just look at the output. So what we've done is we've replaced all of those zeros that were in the data before with NAs. So this is applying this NA if function to all of these columns. And this syntax, if you've read my blog, you've seen me use this syntax quite a lot. And I explain it there. It's another way of writing a kind of anonymous function, kind of like that. It's like a shorthand of defining a function without defining a function. But that's not our focus. So I'm not going to talk too much about that, but hopefully that kind of like is slightly informative. Great. Okay. So why do we want to use tidymodels in the first place? Like, I think the question is like, what's wrong with machine learning in R? So R, pretty much all of the machine learning algorithms and like classification algorithms have been written at very different times and by very different people. And so when you want to run a machine learning algorithm in R, you end up, okay, I'm learning a bunch of different packages. And then I have to figure out, okay, for each package, what's the syntax? So like this GLM function is, maybe that's from base R. I think that might exist in base R. But it takes a kind of formula syntax, which has the outcome, the thing I'm trying to predict on the left, and then the variables I'm trying to use to predict on the right. It takes the data, also has this like family argument, but then the GM net, which is like lasso and ridge regression, which you can also apply to logistic regression. It's kind of regularized machine learning, has a completely different syntax. It now wants an X and a Y, where the X has to be a matrix, which is annoying. The Y, I think often, depending on what you're doing, it has to be like in a certain format, but it has to be a vector. The random forest function has a similar syntax to glmnet, but it wants a data frame instead of a matrix. And then the ranger function wants the kind of first thing we saw, which is also for LM, you know, like they all just want different things and their outputs look very different. And it's incredibly frustrating because I feel like every single time I need to use one of these functions, I would just kind of have to like look up the documentation to figure out, okay, which one needs what syntax, and it's the bane of my existence. Fortunately, we don't have to do that anymore because tidymodels kind of puts everything into a consistent setup. And I think this is like Max Cohn, who's the guy that wrote Carrot and kind of started the tidymodels stuff. He, I think he was working at Pfizer, I think it was a pharmaceutical company. And I think his job was like kind of streamline their kind of analytics, which is really awesome. So tidymodels gives us a consistent way to, no matter what model we want to fit, split data into training and test set, define a recipe for pre-processing. I'll talk about what the recipe looks like and what that means. Specify what model you want, tune your parameters, evaluate and compare models, generate predictions, do things like variable importance. And so it's just the same syntax for every single model that you want to fit. So I'm going to go through all of these steps today because we have a short time, but I'm going to focus on the recipe and the modeling. I'm not going to talk about tuning parameters. I do talk about that in my blog post, and I'll explain how to generate predictions and stuff like that. Yeah, okay, so let's start using tidymodels. So just like the tidyverse, you can load all of the tidymodels stuff with just one package. So that's just attaching or using the library tidymodels. So I think when I wrote my blog post, the workflows and a few of the packages weren't included in tidymodels yet. They are now, so that's really neat. So I kind of want to like start by showing you where we're going. Just so like when I'm, you know, defining a recipe and defining a model, you're like, okay, how are these things going to fit together? I want to show you first. So I can't run this code yet because I haven't defined everything in it, but we want to set up a workflow. You don't have to use the workflow syntax, but I've found it to be the easiest. And so what you do is you kind of initialize an empty workflow. This is for, I want to fit like a random forest model. To that workflow, you add a recipe that will define, which is about your data. And so that says, okay, what's my outcome? What are my predictors? It maybe does some pre-processing. There's a bunch of things that you can do with that. And then I also want to add a model to this workflow, or adding a random forest model that I'll define. I could add a logistic regression model and use the same recipe, or I could use a different recipe, but with the same random forest model. So this is the kind of syntax that we're working towards. And so the way we're going to use this workflow object that we defined. So again, I just want to emphasize like what this pipe is doing, which is this %, is it's kind of like adding functions, it's applying functions iteratively. So it's taking the object defined by the workflow function, and then it's applying add recipe to it. And then we're taking that workflow with add recipe and applying add model. So it's kind of an iterative layering of functions. So the way that we use this workflow object is there's a few kind of functions that we can use with it, but the main one is this fit function. In my blog post, I think I mostly use last fit because I was doing parameter tuning and they're slightly different, but I'm not going to do any parameter tuning. I'll tell you how to do that, kind of. But we're going to use mostly just fit function here. And I'm going to apply that fit function to this workflow, and I'm going to give it a data set to which I want it to kind of run the workflow on. And that's what I'm going to call my final model object. And then you can generate predictions using the same predict function that you would use for any of the other machine learning algorithms that you might have built, and you apply that to that final model, and you give it new data that you want to predict. So under the hood, this predict function is obviously doing something different, but it has the same kind of syntax that you'll have seen if you've done machine learning in R before. Okay, so
quick
yeah.
question.
Yes.
Just question from audience from Melissa. Just making sure I understood correctly, the recipe, i.e. diabetes recipe, is the outcome variable.
No. So thank you for that question. Yeah. So I'm about to introduce recipes. This diabetes recipe is an object that contains a lot of information. And this will become clearer in just a moment, but thank you for asking this clarification. This is not a variable from our data. It's an object that contains information, including what is our outcome, what is the data that we're using, what pre-processing steps do we want to use. So this is an object we haven't defined yet. And similarly with the RF, I haven't defined that yet, but this is what we're working towards. So hopefully this will all make a little bit more sense in 20 minutes.
One more question. Is new data the same as the test data?
That is a good question. I'll talk about that. It could be. It can be whatever you want. So it can be the test data. You can apply a testing data set to that new data argument if you want to generate predictions for that test set, or you can give anything you want to new data. Basically, whatever you want to generate prediction for after you've built a model is what you give to that new data argument and predict.
Thanks.
Okay, so the first thing we want to do whenever we're doing machine learning, if we don't have any kind of external data, is we want to split the data into training and testing sets. So set a seed, because whenever you split your data, it's random. I mean, it's not gonna matter that much. Hey, look, a fun typo. It's not gonna matter that much if you do or don't. I mean, so if you're like trying to like code along right now, my suggestion is to actually just kind of like sit and listen and watch. I personally tend to get a lot more out of just like sitting and then going and doing it myself once I have the picture in my head. But I'm going to do a little bit of live coding because I feel like it's helpful to kind of see, okay, how does this all fit together? But so what we want to do now is we want to define a split object. So this split object, we're going to define using the initial split function, where we're going to give it a data set where we have that diabetes clean data set, and we give it a proportion. So let's say 0.75, because that's what I said I was going to do in my comment. And let's run this and see what that looks like. Okay, so this is something that I found a little bit like off-putting a little bit about tidymodels. Off-putting is not the word, but like a lot of the objects that you define when you print them out, they just like say something. And you're like, is this an object? Like, what have I done? So what this data set object does when I print it out is it just tells me, okay, I've kind of set up a framework for splitting this data set that you gave me into 192 testing data, or assess, I guess is what it's referring to, 576 training or analysis data points. And there's a total of 768 data points in my data set. So that's kind of all that's really telling me. It's not showing me my training set or my testing set. So how do I get those? So if I want to define a diabetes training set, I can literally use the training function on this diabetes split object. So it's kind of like I'm taking this framework and I'm saying, give me the training set. And similarly for the test data, I can use the testing function on the diabetes split object. So I can run that, and then I can look, okay, let's look at the dimension of the training and testing set. This is one thing that I don't love about Jupyter notebooks for R stuff, because it just doesn't look the same, but it's fine. You can kind of figure out what we're trying to do. So this training data object has 576 rows and 9 columns. And this testing data set object has 192 columns and 9 rows. So let's look instead at like the head. So that's the first 6 rows. And you can see that that's just got 6 observations with our missing values because we used the clean data, not the original one that had zeros. And similarly, we could look at the head of the test data. And you can see like the kind of number, the index, I guess, is showing us like which entry it took from the original data set. So here we've got 4, 7, 12 from the what happened to 9? Who knows? I don't know what order they're presented in. But yeah, so this is kind of like a way of extracting the training and testing data sets from this split object. So there's a way to do the tidy model stuff where you don't actually need to explicitly get out the training and testing sets. You can just give a downstream object just the split object, the diabetes split object.
Two questions. Do you recommend stratifying the initial split? I'm guessing what Sarah means by some kind of like maybe imbalanced outcome variable, or maybe she can respond. And then is dim a function in tidymodels or base or another package? Oh, okay, the person.
Yeah. Great. So yeah, fantastic questions. Dim is a base R function for showing the dimension. And so it shows us, it prints out a vector of length 2. I guess, things look a bit funny in Jupyter notebooks, but the first entry is the number of rows and the second entry is the number of columns. Thank you for asking that. And then head is also a base R function for showing the first 6 rows. And the other question about the stratifying, yeah. So in general, I think like if you have something that you care about making sure that it is equally represented, like whether it's like, you know, a particular category in your data, you could do it based on the outcome variable. If you care about, if you have like an imbalance, you want to really make sure you have enough information in your testing data, you can totally stratify. I think there are potentially arguments. Yeah, there's like a strat argument that you can give, which I guess you would just give like, yeah. So if I just did that, I expect maybe now it is head, that's the word. Yeah, I suspect that by giving like a strata equals diabetes argument, it's now ensuring that that proportion of diabetes in the original data set is kind of retained in the testing and the training data. In the interest of time, I'm not going to explore that so much, but hopefully that answers your question.
And then can you comment on the split of 75-25? Is that arbitrary? Why not 80-20? And then is it possible to split sequential data? So for instance, 25%, but sequentially. Suzanne, I'm not quite sure what you mean, but maybe Rebecca can comment.
I think I know what that means. Like if you have like data over time and you want to like take the last 25% as the test set.
Okay.
Yeah. So the 75% is really arbitrary. Like my general feeling is like your training set should be at least 50%. If you have a small data set, you want to make sure you have enough information in your test set. I actually usually do a 3-way split, but back when I wrote my blog post, at least there wasn't really a way of doing a 3-way split into training, testing, and validation. So just kind of stick with the two-way split to keep things simple. But you could do 60-40, you could do 80-20. I tend to, if I have a lot of data, will be more likely to have my training set be a higher proportion of my entire data set, mostly just because then I know even my testing, even though it's small, it still has enough information to get a reasonable kind of assessment. But 75-25 feels to me like a reasonable split. 70-30 also equally reasonable. You know, it's mostly like a judgment call that you want to make.
Thank you.
Okay, so we've defined like our training set and our test set. And so now let's define a recipe. So the first thing that you do in a recipe is you need to define an object with the function recipe. So I'm writing this on a new line. Let me not do that. That might look confusing. Recipe. Okay, so I'm using the function recipe, and I'm using that kind of formula syntax that you might have seen before. And I showed a few examples very briefly at the beginning. So the thing that I write the variable that I write the first is the thing I'm trying to predict, which in this case is diabetes. And then I have a tilde that says, okay. And then, so on the left-hand side of the tilde is the thing I'm trying to predict. On the right-hand side is the variables that I want to use to predict. So let me copy paste here. So in this case, maybe it's all of my variables. Which is pregnant, glucose, pressure, blah, blah, blah. A shorthand way of doing this. So the plus syntax typically is just like kind of convention. It's just like, we're not, you know, if I had times, it would create an interaction. I'm not going to talk about that. But it's just like, it's kind of a convention way of saying I'm kind of linearly It might not be linear, depends on your algorithm. But like these are all of my features that I'm using, and they're not interacting with each other in any way. So a shorthand way of saying I want to predict using all of my variables is just to use a dot. And this is kind of just a little distinct from the dot that I used earlier that I didn't want to talk too much about, but you might have seen this before. So this is just saying predict diabetes using everything that is not diabetes. I'm going to keep it as the original one, just kind of because I think it's a little clearer. And I need to tell it where do these variables that I'm referring to come from? And come from diabetes clean object. So there's a note about this thing that I provided that I'll talk about in a moment. So that's kind of the basic recipe, which says, okay, this is the format of my model. Format, like this essentially assigns the roles of each of the variables. So essentially the outcome and the predictors. But you can add a lot more to your recipe. So I'm going to pipe this recipe into some steps. So there are all these step functions. So let's do a normalization step just for fun, where I'm saying, okay, I want to normalize a bunch of my variables. And so the way you specify what variables you want to normalize, there's a few ways you can do it, but I just want to do this to all of my numeric variables. And so there's several functions that are like all numeric, all predictors, all categorical, which means you have to kind of say them by name. And I want to add another step again with pipe, where I want to impute. I want to do a KN imputation. Impute, not imputation. Talking and typing at the same time is challenging. So what I want to do here is remember how I replaced those zeros with missing values? Most algorithms are going to be super happy if you give it missing values. And so I want to use a KNN algorithm to impute them without having to actually do that myself. And so fortunately, if I just put this in, it will do it when I train everything. And I want to apply that to all of my predictors, which all of my predictors are probably numeric, but I just want to show you that there are different kind of ways of referring to your variables. So let's run this and look and see what it looks like. So again, like the tidymodels object is kind of just given us like a bit of text, you know, it's like not really showing us, it's not like an object that we can really look at. It's just kind of telling us, okay, we've got some inputs where we've got one outcome variable, 8 predictor variables, and I'm going to perform some operations, including centering and scaling. That's the normalization, and the k nearest neighbor imputation for all predictors. So the important to note is that we haven't actually done these operations yet. We've just written a recipe for doing them. So we've said what we're going to do without doing them yet. So one thing I want to point out is I used data equals diabetes clean, but I could have used data equals diabetes train or even data equals diabetes test. So it doesn't matter that much what data you specify in your recipe because we're not actually running this yet. The only thing that it takes from that is the variable names and the type of the variables and a few things like that. You can use any of those three data sets, which is the diabetes clean, which is the complete one, the training one or the testing one, and you'll get the same thing. If you want to apply the recipe, does anyone have any questions about that before I move on?
There were some questions about the data attributes. Could the data attribute in the recipe function, I think there's a word missing, in the training set? There was a question about normalization and whether that was the same as feature scaling, but you already answered that. What should we take into account when choosing imputation algorithm? Is k nearest neighbors the most commonly used? I'll pause there for a minute.
That's a good question because I feel like there are not a lot of really good imputation methods out there. And a lot of them are just really slow and hard to actually implement. One that I found it's like based on random forest, it was maybe from a group at Stanford, if anyone knows what I'm talking about, put
There
it in
is
the chat because I can't remember what it's called.
There's somebody who's asking if they can impute using recipe random forest.
Yeah, I don't know if they have implemented that yet. They might have. I haven't looked explicitly. We can look in the book. I don't know if they have a section for imputing. So it's a recipes thing. Imputation. Yeah, I'm not entirely sure. But there are a lot of options, like I've just kind of like shown like one imputation option. There are quite a few, and I don't remember what they all are. The one I use most often in this is probably just KN impute. Unless my data is really big, in case it's really slow, and then I might do something else. I don't know. I'm not super pleased with the imputation options in general, not with tidymodels specifically, just like in the world.
And are there normalization techniques for categorical variables, or how do you deal with those? You talked about numeric.
So there are a lot of other things like to do with, maybe we can look to some of the step options. Step, recipe, recipes. There are so many things that you can do. I want them to give me like a table. I feel like it exists. Yeah, here are some examples. You can turn things into dummy variables. You can replace levels of a categorical variable that have below like 1% of the observations having that level as other. You can do a log transfer. I don't know if they have like the table that I'm looking for. I think on the website, there is such a table.
Got it.
Yeah, they've just got, you can add interactions, you can NS, I don't remember what that does, but there's like a lot of step options. Normalizing for categorical variables, it specifically doesn't really make sense, which is why I specifically said just do it for all numeric variables. Let's see what happens if I try, although we don't have any categorical variables, do we? Except outcome. Yeah, I can't show you for this example. But if you just have one and you try, I think it just gives you an error, is my guess.
And I'm guessing you can write custom functions inside for the recipe.
Yeah, I think you can. I have never done that. But I remember reading about how you can make your custom steps if you want to. I don't know how to do that, so I can't show you.
There's
awesome.
One question about diabetes_clean versus train. May I unmute? Yes, you can.
Hey, thanks, Stephanie. This is
Sure.
Sharon. I have a quick question regarding the data argument. And you said that it's okay to use either diabetes clean or diabetes train. I remember taking a tidymodels workshop, and they were really emphasizing that I'm not really sure it was here or like later on, but if we use like the entire data set here, the normalization may be done on the entire data set, and that may lead to some test data leakage.
Yes.
So I'm not sure if we should use train here, or is that a later step that I missed?
Yes. So this is a really good point. And I was actually about to talk about this. So thank you for like preempting what I was about to talk about. So the fact that, here it's literally all it's doing is taking information on like, okay, which variables are the outcome, which variable are predictors, which variables do I want to normalize on, as in like which variables are numeric in this case, not actually implementing the cleaning. When you actually implement the cleaning, then you want to make sure that you're kind of prepping it, which is what we're about to do. So we find a recipe and we want to prep it. You want to make sure that you're going to prep it on the training. So, and that's exactly for the reason that you're saying. So like if you are using a bunch of information from your training data or that, from your testing data, which is included in the original clean object, then you kind of lead issues with like data leakage. If you've heard of that. So that's kind of like this idea that if you're using information, normalization is a good example. Like let's say you're subtracting the mean, but you're using the mean, that mean is involved is based on the training and testing data together. Then you have information in your kind of cleaned in your training data when you prep it, when you apply your recipe, that is from the testing data, and they're not as independent anymore. So what I'm saying here is that you can use any of them when you're just defining the recipe, but when it comes time to actually prepping it, which I'm about to show you how to do, you should use the training data set. So when you want to prep the data set, this is essentially saying, okay, so now I actually want to like write the code that does these steps, like you're not writing it yourself, but like it's now saying, okay, this is physically what we have to do to this data. I want to give this prep function the recipe object, so diabetes recipe, and then I need to give it a data set, where in this case, I want to use diabetes train. So now with the prepping of the recipe, it's kind of like, okay, now we're actually gonna base, we're ready to implement the steps, rather than like we're just getting information from the data. And this prep object, again, like the other ones, doesn't really, let me print it out, doesn't really show us anything. It doesn't look any different. But it now says, okay, I now know what the specific variables are and what the actual data is. It has a little bit more information. And the real thing when you actually apply it is when you bake it. So it's kind of cute. It's like you write a recipe, then you prepare it, you get all your ingredients together, and then you bake it. You actually like create the object that we're trying to create, the pre-processed object. So we bake this prepped object, and we apply that baking to some data. Yeah, you have a question?
Can you think of prepping like a cookie cutter, like the cookie cutter being a cookie cutter?
Yeah, maybe. I'm trying to like this metaphor, I feel like has a lot of different like, so there used to be like a juice step and people were like getting really confused with juicing, and now they got rid of juicing and they just have bake, and it's really cute. I think it's maybe not the clearest metaphor. Like I feel like having like actual function names that describe what you're doing rather than based on a baking metaphor might be more helpful, but it's cute. So, but you can just think of it as 3 steps. It's like define the recipe, which is like you're not actually doing anything. You're just specifying, okay, this is my outcome, this is my predictor. I'm not doing anything with the data yet other than identifying what's what. Prepping is like, okay, now I'm actually getting all the stuff together. I still haven't really done anything, but now I know specifically what the recipe relates to in the data. And then baking is when you're ready to like apply it to something. So with baking, there's an argument called new data. So I'm baking this prepped recipe and I'm applying it to new data, where if I write new data equals null, so I'm not giving any new data, it's going to apply it to whatever data set I gave to the prep step. So it's going to apply it to the training data set. And so if I look at
are baking and juicing interchangeable then?
They are now, but baking is more general. So juicing is specifically extracting the pre-processed data. Baking now can do that. So, but baking also just implements the thing. Yeah, it was more complicated. Now it's still complicated, but it's slightly less complicated. Yeah, so I could also, I suspect, I'm saying this out loud and hoping that it's true. Instead of giving new data equals null, I could give new data equals diabetes train, and hopefully it would give me the same thing. Yeah, it does. So it's just kind of like, okay, I've prepared this recipe on the training data because that's what I gave it. And if I'm not giving it any new data, it's just going to bake it based on the data that I've given it. If I want to then apply that same recipe to the testing data, so like this new chunk down here, I can apply it to the diabetes test data. And then I will get that for the diabetes testing data set. Although it doesn't seem to have scaled anything. So that's a bit useless. Why didn't it do that? Did I not run something? Oh, because I'm giving head diabetes test. I understand. I should be looking at the head of the pre-processed version. Okay, yeah. So this works. Good. I was like worried I'd done something wrong. That's kind of a lot, recipes are kind of confusing. Does anyone have any questions?
Nothing in the chat yet, but.
Right. We can come back to it if you do. Okay. So remember where we're heading, right? So we're halfway there. And hopefully, because we have 7 minutes left, we are more than halfway there in terms of time. But so remember that we wanted to fit this random forest model. So we first kind of like initiated an empty workflow. I haven't run this code yet, but this is what I want to run in a moment when I've defined all the things that I need. I want an empty workflow and I want to add a recipe. So I've now defined my diabetes recipe. Notice that I'm giving this add recipe function just the recipe. I'm not giving it the pre-processed data. I'm not giving it any of that kind of stuff. I'm just giving it the recipe that I defined. And I want to add a model, which is the random forest model that I haven't defined yet. So we still need to define RF model. So great. When you want to specify a model, there's a few things you need to tell it. So you need to say what the model type is. So like, do you want random forest, logistic regression, support vector machine, neural network? You want to specify any arguments or parameters. That's not required, but if you want to do that, you can, and you can tune them if you want to. You need to specify the engine. For example, what package, like if you're doing random forest, do you want it to be from the random forest package or from the ranger package? So the thing about tidymodels is it's for the most part not implementing its own version of any of these packages, of any of these machine learning algorithms. It's just taking all of the ones that exist already that have been written by other people and giving it a common interface. So any like there's a list somewhere on the internet of like all of the potential models you can fit. And you also need to give it a mode, which is, are you doing classification or regression? So
couple of questions. Can any recipe be mixed with any model type?
Pretty much, yes. There are some things that you're going to find where it's like, you know, some certain models have certain requirements. Like maybe like, you know, if your data has categorical variables, but the thing you're trying to apply, the model you're trying to fit only accepts numeric ones, you know, it will be happy if you have like a dummy step where you're converting all of your categorical variables to numeric dummy variables, but it's not going to work if you don't do that. So like there are some kind of constraints, but for the most part, yes, you can. And that's why it's so powerful.
When making the test set, is normalization based on the mean/standard deviation of the training data or the testing data?
So it should be the training data. So that's the thing about prepping. So let's go back. That's a very good question. And that's a very important point. You know, and I said that confidently, but I'm actually not sure. But I think it might actually just be doing it for itself. That's a really good question. Which one is it doing? Does anyone know? If anyone knows, can you put that in the chat? So the way I think about prepping is that it takes the data set you gave it and it defines a function, let's say subtract 7, because that's the mean from the column of glucose, and divide by the standard deviation, which is 1.2, you know, and my assumption is that it will apply that same standardization to whatever data set you give it, because that's what the prepping is doing. So my guess is that it is basing that normalization when you apply it to the testing data, it's basing it on the information from the training data. Yeah. That's what I assume. And I don't know that. I'm like 90% sure that's what it's doing, but I'm, you know, I haven't looked at the source code and I'm sure it says somewhere. I haven't read everything that there is to read. But yeah, that's my assumption.
And then there's excitement about one of the coolest parts of the recipes that they're applied individually to each fold of the cross-validation. Is there a plan to talk about that today?
Unfortunately, no, because of time.
Yeah.
But I do talk about cross-validation in my blog post as well. And I'm sure there's a whole section in the book, in this book here, about that. But unfortunately, 45 minutes is a very short period of time to to display things. I'm trying to just give recipe, model.
Thank you.
But there is a lot of information out there, but yes, there are really nice things for like resampling and cross-validation that work really nicely with recipes. And so like, that's a really good thing to mention for those who might be interested. All right, so let's define a model. So let's define a random forest model. So what you do is you define an object that is like the model type, which is a function. It's like a function implemented. It doesn't really matter. Just say I've got a random forest here. And what I want to do to that is I want to set some arguments. I'm specifying an argument, which is mtry here for the random forest machine learning algorithm. Mtry is like the number of the number of features that you try at each split. I'm not going to go into the details of what random forest is doing, but this is an argument that you need to, or like a parameter that you need to specify. If you want to tune that parameter, so you want to like kind of do some cross-validation to figure out, okay, what value of this mtry argument is going to give me the best performance, you would change this mtry to tune. But I'm not going to do that. Because we have 2 minutes. Then you need to set the engine, which just says, okay, what package do you want it to come from? Here, you can also specify what importance, like this is often like other arguments that you would give to that function that you would use. And you want to set the mode as classification. That could be regression if your outcome was continuous. So let's define that. Another example, because we have so little time, I'm just going to copy and paste.
You can take an extra few minutes.
All right, well, I'm going to type this out then. Challenge accepted. Well, I'm almost done, fortunately. But if I wanted to do a logistic regression model, then I could define it to be typing, not my forte, a logistic reg object, and then I can set the engine to be from the GLM package, and then I can set the mode. I'm not specifying any arguments because logistic regression doesn't really have any that I care about, and I'm going to set the mode to be classification. And again, it didn't really print out anything. I wonder if I have this in the next chunk. Yeah, so let's see what happens like if I just like print out RF model. Again, it's just some text. So like a lot of the stuff, the tidymodels objects, when you print them out, it's just giving you text information. Where here it's saying random forest model specification, classification, telling me the arguments, and the importance is impurity, because I just specified that up here, and it's giving me it's just like summarizing exactly what I wrote in the code, but it's not actually showing me any kind of modeling object. And I haven't fit this model yet. Notice that I haven't given it any data anywhere. This is like the recipe. It's like a recipe for the model, right? I haven't done anything yet. I've just kind of written a model recipe, but they don't call it a recipe because there's already a recipe. You can't have 2 recipes. That's too complicated. Yeah. Okay. So now we're at the point where we can combine all this stuff. We're kind of going to do the thing that I said we were going to do the whole time, which is first we want to add a recipe where we called our recipe diabetes recipe. And then we want to add a model, which we called RF model. So it's like the recipe for the pre-processing and then the recipe for the model. We can run that and we can look at it. And again, just gives us some text where it says, okay, the model that we're doing is a random forest. The preprocessor is a recipe. There are 2 recipe steps, which is the normalization and the KNN impute. And we have some stuff for the model that's just printing out the same stuff as before. So again, we haven't fit this yet because we haven't given it any data at any point. We've just put it all together in our workflow.
Speaking of, are there other things that can go inside of workflow, open parentheses, close parentheses?
Great question. I don't know. I'm hitting tab and nothing's happening.
Fair enough.
That would bring up the list of arguments, which implies, I suspect there probably are, but I don't know what they are. I've never put anything inside workflow. But it's like a nice thing. It took me a while to kind of get my head around all of this. But I think it's easier now. There are more resources now than when I was trying to do it. So, okay, so now we've kind of got our combination recipe. We've kind of concatenated our 2 recipes, our recipe and our model recipe together into one big workflow recipe. It's also a recipe. Everything's a recipe. And we want to like actually do something with it. So now we're going to fit the first argument of fit is going to be the workflow. So RF workflow, and we're going to give it some data. So this is where it's like, okay, this is the data that we want to give it is diabetes train, because what this is going to do is this is going to run a recipe and fit the model on whatever data set I give it. So if I gave it diabetes clean here, it would run the recipe on diabetes clean and fit the model on diabetes clean. Like I showed earlier, like how you can like prep and do all that stuff with the recipe. You don't actually have to do any of that because we're just using the recipe we've defined. We haven't, this recipe, this object hasn't been prepped. It hasn't been baked. It's just been written. And so now is when it matters, like what data set I really give it. And so I want to give it the training data set because it's going to run the pre-processed stuff on whatever data set I give it. And again, if I just print out this RF fit object, it's just more text. But now this is looking like something that you would get as an output from a model, right? If I ran that ranger function, this is what it would show me, which is, you know, it's telling me the out of bag prediction error is 0.15, which is very exciting. Okay, I think next thing I'm going to do is just a quick recap. Sorry about all that screen shifting. I was trying to figure out what comes next. And then we're done, kind of, mostly. So I just want to summarize everything that we've done. So the first thing we did is we took this diabetes clean object and we split it. We did 0.75, whatever, using this initial split function. And then we extracted the training data set using the training function. We extracted the test data set using the testing function. We defined a recipe. We defined a model. And then we put it all together in a workflow. And then we fit that workflow to the training data. So I'm just going to run all of this. And looks like nothing happened, but things happened. Does anyone have any questions? This is kind of like trying to put it all together. Hopefully there's like a narrative in your head now of like, okay, really there's like two things I'm doing. I'm defining a recipe and a model, and then I'm putting it all together, and then I'm fitting it.
There is I guess like a comment / question from John. He says, I wonder if you learned this, if things like Keras or TensorFlow would be more intuitive as you build out the network and then compile the model and then fit it.
Yeah.
Does this work for neural networks?
Yes. So there are neural network engines and functions that you can fit. I haven't played around with them too much because I was mostly doing this like on my laptop, and my laptop that just got replaced was just kind of crap and was not happy. But yes, there are kind of like underlying like TensorFlow and stuff like that implementations.
Yeah.
Fun fact, I now have a new laptop, and the reason I'm doing this not locally on my computer with this notebook is because I got one of those M1 MacBook chip things. And I cannot install Jupyter Notebooks and R. I mean, I can install those things separately. So like RStudio is fine, Jupyter Notebooks with Python, fine. Jupyter Notebooks plus an R kernel, not so fine. And I was lazy, so I just gave up. I think the problem is too new.
I've also heard M1 chips can't have more than one external monitor as well. That seems
I'm using two. Oh, actually, no, two external monitors. Yeah, I don't know. I'm using a single external monitor.
Apparently that's possible. Okay. There's a technical question. Have you ever noticed RStudio hanging briefly when you run tidymodels code? Sometimes it will take several seconds to implement.
I mean, some of the stuff is slow, but I don't think that's tidymodels' fault often. Yeah, I haven't specifically noticed that, but I mean, that sounds like a thing that could totally happen.
Yeah.
Cool. All right, so one final thing. If you want to use that fitted object to generate some predictions, you can use the predict function on that fitted object. You can give it whatever data set you want to predict on. Let's say we want to predict on the diabetes test data set. let's look at the first 6 rows. Diabetes, test pred. It's so hard typing. My keyboard is so loud. I apologize. So what this is doing is it's giving us the class predictions for all of the observations in the test set. And I'm just showing the first 6 of them here. So they're mostly negative with one little positive in there. And this is this diabetes test pred object I've just defined. It's technically a tibble, which is like a data frame, a single column data frame in this case. And I want to like create another data frame, which I'm going to use to kind of get things like the accuracy and the sensitivity and stuff like that. So let's look at this. So I'm just taking that one column data frame and I'm transmuting it. If you've never seen transmute before, transmute is a simultaneous mutate and select. So you can mutate within it, but it'll only return the columns that you're defining within the transmute function. So what this is doing is it's transmuting this one column thing so that I have a column called pred that is just that original column that was .pred class. And I'm adding a column that is truth, which is the true class. And so I just want to have this 2 columns. This is like the prediction. This is the truth of the outcome. And then you can calculate metrics by just chucking this data frame into the accuracy function, which is originally from a package called yardstick that's now a part of tidymodels. And I just say it has 2 arguments you need to give it, which is what's the prediction, what's the truth, and it's just the column names. And it tells me, okay, the accuracy is 0.75 and spec is specificity. And the specificity, I can never remember, it's like true, positive, or true, whatever. One of those ones is around 0.7. And so like that was just like kind of getting the predictions, the predictions from the fitted object, and you can do things with them. Finally, the last thing I just wanted to point out, this function exists, didn't used to exist, which is pull workflow fit. There's a bunch of pull functions which allow you to kind of pull the object from this fitted object. So this is just pulling out the ranger object in case you want to do something with it. Yeah, that is the end of my talk. Hope you all learned something.
Is a ranger object a data frame, or what is, it's like an S4 or S3 object?
Yeah, so I don't like, it's not a data frame. It's like, you know, if you run SVM or random forest, or like you get something, I don't know what it is. It's not a data frame. It can often be converted into a data frame, but Ranger is a version of random forest. It's one of the packages for doing random forest.
Okay, we have a slew of questions.
Right.
Compare the pros and cons between tidymodels versus Caret.
So Caret, in my experience, is a lot slower. It was also a lot more cumbersome. Like it wasn't quite streamlined. I haven't used Caret in quite a long time. I think I have a blog post on Caret actually, which is embarrassing when I'm saying I don't know Caret. But yeah, I think it's just generally more efficient. You know, it's kind of like when you write something the first time and you're like, oh, now I've done that, I can see so many better ways of doing that. I imagine that's what tidymodels is, you know. It's like, okay, I did Caret. It's kind of, it's fine. The idea is there, but I see better ways of doing this. And then I think they're like, okay, let's just do a new thing. I forgot what the question was and I probably didn't answer it at all, but there you go. Just
pros and cons between Caret and tidymodels.
Okay, actually, probably the biggest thing is that tidymodels is going to be continually updated. Caret is kind of becoming obsolete. It's not going to go away, but if you're going to learn one, definitely tidymodels.
I've heard similar things as well, but the tidymodels framework seems to be like changing rapidly though as well.
It is, it's new, and they've also kind of just like hired a bunch of new people to work on it, I think. So it's like, but you know, to be fair, I wrote my blog post a year ago and the changes between now and then in terms of what I wrote are subtle. There's not a lot of really big ones. That the workflow idea is still kind of like, as long as you have that, the small changes aren't so jarring, you know?
Do you have a way to compare performance across multiple models?
Yeah. So you can apply. So there's a few different things. So you can define several different fitted models. You know, like you can I've defined RF fit. I could also define LR fit, logistic regression fit. I could define a bunch of different fits, and then I can create tables of these kind of accuracy metrics and stuff like that. And there are times when crazy things like list columns come into play, but you don't need to do anything with those. But yeah, I mean, you can just like define a few objects. You know, you can probably use some fancy per stuff, but it's not necessary to kind of iteratively apply things to different things.
Okay, there's a comment about still struggling to understand the difference between prep and bake. Would you mind quickly explaining that again?
It would be my pleasure, mostly because I'm still struggling to understand the difference. Yeah, let's do it. Let's go back. Where did I have this? Yeah, so the nice thing is like if you're using the workflow thing, you don't actually need to ever use prep and bake if you don't want to. Workflow, still workflow. Too far. I went too far. Okay, that's where we're heading. Splitting into training and testing, extracting, recipes. Here we go. Okay, so the way I think about it is when I write the recipe, I'm not going to use a baking metaphor because I think that's confusing. When I write the recipe, I'm literally just like, it's like I'm defining an object that is this formula right here. It's as if I'm doing like, okay, formula is this, and maybe it would be like, you know, in quotes, there's like some formula function, but whatever. And I'm defining a function that says like, you know, normalize is a function where I give it some data and I do like data minus mean over SD, you know. So the way I think about, you know, and I also do like KNN, impute, whatever. Let's pretend I'm just normalizing and I have a formula. I think of writing the recipe as I've just defined these functions or like this object or like, you know, like I haven't actually like run them yet. And then I think of prepping as being like, okay, there's another thing here. I think of prepping as being like, oh, actually, it's not just data, it's diabetes train. And I want to do diabetes train over this. And I still haven't run it. Still haven't run anything, but I now explicit, you know, it doesn't really make sense to define that. Like it's, you know, whatever. This is not quite a perfect analogy. But you can kind of think of it this way. And I still haven't run it, but I'm now saying, okay, this is specifically, okay, this is how I would do it. This is a better analogy. It's still just like you can give it any data set you want, but now I know the mean that I'm talking about comes from diabetes train because of what I gave it to prep. And then bake is like, I'm actually like applying normalize to diabetes train. Ignore the formula stuff. Does that make sense?
Yeah, well, we will let Ruben ask.
Yeah,
yes.
Yeah, like it's like I think the main thing is like, okay, so I had that general function, I knew the format of what I was going to do, and now I'm actually okay, I'm going to do it based on this data set that I've prepped it, but I'm still not implementing it yet.
Yeah.
And now when I implement, I'm implementing it to whatever.
So there is another question. Can you have several models, I guess, in one recipe? So here you've got one model within one recipe. Does that extend to multiple models somehow in one recipe?
It might. I don't actually know the answer to that question. I don't think it did when I started learning about this stuff, and I've used it a bit since then. But I think there have been a lot of changes that I'm probably not aware of. I'm aware of something called it's got pancakes in it, ensemble thing. What's that called? They're like they're baking, but there's a pancake ensemble package that I can't remember. Stacks. It's about stacks. I don't know. But it's that exists. And that's a way of like creating ensemble models, which is like combining models, not so much like, I don't know if I don't know how to answer questions well. But, you know, you could define many different workflows, and you could run those different workflows that have different combinations of recipes and models and stuff like that. But yes.
Yeah. Seems like Stacks is the package for Ensemble. Confirmation from the crowds.
Okay. Yeah. Nice.
Okay, question from Sarah. Can you create a multi-output recipe?
Depends multi what? Like, oh, as in like multiple regression, like you have multiple outcomes.
Sarah, feel free.
Maybe that's what I think. Yes. If that's what you're asking. I've never done it, but
okay. Let Sarah respond. And then are predictions always applied to the test data? From Melissa.
So you can apply predictions to whatever you want. You can you can make up some data, apply some predictions to that if you want to. You can do whatever you want, as long as the variables are the same. It's the reason that I'm applying it to the test data is because when you're doing machine learning, typically you want to have some kind of independent data set to evaluate what you've done, just to make sure that your algorithm isn't kind of just finding like random noise and like creating, like, treating patterns that it finds like, oh, these are legit, when like it doesn't know that. You have to like check it, you know, you have to check that those patterns also exist in other data that is maybe from the same source, maybe not. And usually you don't have any extra data lying around, and so you split your data into training and testing, right? It's kind of like a pseudo external data kind of situation. And so it's very common to generate your predictions on the testing data, because then you have like, okay, I'm generating my predictions on my testing data because I want to be like, how did it perform on my external data? But you can also generate your predictions on your training data. It's just not going to be a independent assessment of performance. But if you want to calculate residuals, for example, if you're into stuff like that, then you can totally generate your predictions on your training data. You can give it what you want. It's just kind of common in machine learning to evaluate on the testing data.
There's a longer comment about Mimis is interested in implementing a neural net, but does not have a way at getting the ground truth. So instead, I want to implement an optimization function that allows the network to compare its performance and learn from its mistakes with respect to a desired outcome. Can I do something like this? I'm not sure if you're familiar, or if you don't feel comfortable. Maybe yeah. Okay.
I always feel comfortable. I just feel comfortable telling people what I don't know. Yeah, I don't know. I mean, that sounds like a thing that might be a specific like thing that you would need to really get deeper to the kind of neural network package that you're using. And tidymodels might not be the route that you want to take, just because you're going to want to do a lot of tweaking, and sometimes doing like kind of low level tweaking is hard. I'm not super experienced with the neural network part of tidymodels, but I think it's pretty basic. You know, it's like you tell it how many layers you want, bam, you go. I suspect no. The answer might be yes. I don't know.
There's a question from Mohammed about combining several algorithms. I'm guessing that was kind of, you touched on that when you created like the several data frame output objects, like the specificity. Mm-hmm. So yeah. Okay, Melissa asks, how do we interpret the results coming from the parsnip model object when using the pool_workflow_fit?
Yeah, so this is like what you would see if you had just run Ranger. So let's run Ranger. Does it show me the formula? No. What's the thing? Diabetes train. Let's just run this. Well, I have to do library Ranger. And I still did things wrong. What's your problem? Missing data because I have to get the pre-processed one. Pre-processed train. This is like how I do things. I just talk to myself. It's very embarrassing. Okay, great. So this pool workflow fit thing just gave me what I would get if I had run the Ranger function directly. And so it's not so much that you might interpret this as this might have, let's call this Ranger object. Let's run that. And Ranger object might have things that I want to access. Like I don't know, what importance mode. Let's say I want to look at the confusion matrix, and I now get that from there. I can, let's find this also. Here, let me think about it this way. Workflow Ranger is what I'm going to call this. And let's see if I can get the confusion matrix from that. I cannot. I don't know what it does. I've never used it. But maybe there's like a fit thing. I don't know. What does it say if I hit tab here? Oh, it says it's got things. It just doesn't look, I think I just chose the one thing that it doesn't port. Num samples, great, let's do that. Null. Yeah, I don't know. I literally saw that in the book and I was like, oh, that's cool. I'm just gonna put that in there, but I've never actually used it. So I haven't done my research on this one. You know, if you do, you should let me know what it does. But it's related to extracting the original underlying object. I know that much.
Nice. There's a comment or a question from Jenna. Can you briefly mention how to do tenfold cross-validation, or can you point us to some resources about it?
Yes. You know what? I know I wrote about this in here. CD. Yeah. Okay. So this is a blog post where I wrote about things, apparently. Where there's this function vfold CV where you can give it whatever data set you want. In this case, I gave it the training data set. Let me actually like do this. Repurposing these little cells. And you can give it an argument V, which is like how many folds you want. And so this would be a tenfold cross-validation on the diabetes train object, diabetes CV. And it looks a lot like, hello. Okay, so what it does is it gives you, see now, because I'm in Jupyter Notebooks, list columns look weird. But it gives you like a list of the kind of like IDs for each of the folds. So this is like the first fold. And this is like a vector, this first entry. Yeah, Jupyter Notebooks, oh, well, sorry. Jupyter Notebooks is not the best way to show this, but you can use this. Let me see what we did in here. Where do I use this? Yeah, so this is when you're tuning parameters and define a grid. So I want to try 3 options for mtry. And I can use this tune grid object where I give it, tune grid function, where I say, okay, I want you to tune these parameters based on this cross-validation object. The grid is what I just defined here, and I'm specifying the accuracy, and it kind of gives you some stuff. And you can collect metrics on that. And yeah, I think in summary, like it probably has quite a lot of information on using cross-validation in the book. And I seem to have written about it in my blog post. So there are resources.
Awesome. There's a comment or a question, I guess, from Pavitra about a resampling question, which is too long to type. Can you unmute yourself? Yes, if it's brief.
Hi, Rebecca. Thanks. Thank you, Stephanie. So Rebecca, in his book, he says that he, when he does a cross-validation, he does it on the training set, and then he uses 90% for the resampling part, and then the 10% is for the estimation. So when he does that, does it mean that, okay, so I'm just having conceptually, I'm having a hard time figuring this out. So let's say that the data set is like 100 in the training, and he's creating a 10-fold cross-validation. So I presume that they happen in parallel, correct? So the first one, I mean, they're all going to be like the 90-10 split, let's say, but it's the same 100 which are replaced each time, and in parallel he creates 100 entries, but it's just that they are resampled differently in what ends up in your in the fold which is actually used for the testing, and the fold that is actually used for the estimation. Is that correct, that they're happening in parallel?
Yes. If I mean, not necessarily computation parallel, you might do one after the other, but yes, I mean, it would have like essentially what it does is it defines, okay, like I've got this, like the way cross-validation works and the way I guess it's implemented in this situation is like, it's like, okay, I've got like my first fold, which is 90% of the data. So like if I'm thinking about 5 cross-validation, I think about it in terms of like, I split the data into 5 distinct subsets. The first fold is just the first 4 of those. The second fold is like the first and the third, fourth, and fifth. Third fold is like the first and then you just like remove one. Like I think I have to like draw things in my head. But like they're overlapping these folds, but they are this distinct subsets. They're only overlapping because they're using some of the same distinct subsets. Like a fifth of them will be different, if that makes sense. I didn't explain that well.
Yes, thank you.
I think your understanding is correct if I understood what you're saying.
We'll take one last question. Does the Rise package with Jupyter have built-in shortcuts like RStudio, such as Command-Shift-M for the pipe?
I can never remember what those shortcuts are. Right, Command-Shift-M. Let's see. Which one's Command on my laptop? Let's use this one. Command-Shift-M. Yes, it does. Neat.
Nice. Oh, that's really nice.
Yeah, because it's just a Jupyter notebook. So like the plugin itself is just turning the Jupyter notebook slides. It's not like changing anything about the underlying, like each of these like not called chunks, they're called cells, I guess. It's not like these are still just Jupyter cells.
Nice. Well, I think I got all the questions, but if I missed one, feel free to ask again. Otherwise, we all owe Rebecca a huge round of applause for this. This was amazing. Thank you so much for presenting today. It was a very lively conversation. I for sure learned a lot.
I'm so glad. It was my pleasure to be here.
Awesome. All right. Well, I look forward to hopefully seeing most of you at the next meetup next month. Feel free to reach out to us on Twitter or by email, check out our website, or join our Slack workspace. All right. Take care, everyone.